Hi, we are ITO Price Prediction. This is a web app we designed and built that predicts the future RAM chip prices using machine learning. It's built for anyone who needs to track component pricing, from hardware resellers to procurement teams. At the core of this app is a predictive machine learning model trained on over 3 years of RAM pricing data. The interface is simple. Choose a RAM type, input the values, and the app gives you a predicted price. Behind the scenes, there's a lot going on, but for the user, it's all seamless. At the beginning, the 5 of us were given a Google Drive with tons of data, and were told to use it to predict RAM chip prices. We quickly analyzed the data, grouped it together, and converted it into CSV for Python use. We ran correlation tests, graphed prices over time, and began to build a solid understanding of the data and how we needed to use it to fix the problem. We decided to make a machine learning model to predict the prices. We went with XGBoost as it was fast, accurate, and meant for nonlinear data, which, as you can see from the graphs, is quite common. We trained it on all the data at first, which provided amazing results. But we realized that there was a flaw. If we were going to have people use it, the people would have to input over 100 different values, which is not cool. So we found the top 5 most impactful features that changed the price, and it still retained about 95% efficiency. These 5 features being analog devices volume of stocks traded, ASML volume of stocks traded, Euro exchange rate, Chinese yuan exchange rate, and Japanese yen exchange rate. Now, with the models trained, we went to work on the UI. We used a Python library called Streamlit, a simple library used to make web apps. We did this to seamlessly import the models as well as make sure our website looks great. We uploaded the web app to Streamlit's own personal hosting service, and you can find our website here, ito-priceprediction.streamlit.app. Let's see it in action. First, we will try a DDR4 4GB RAM chip. The model was not trained on this data, so we can use accurate stats and see if it's close. The date will be October 9th, 2019, and here are the values for that day. We put it in, hit generate, and boom. Now let's compare. They're both pretty close, contract price only being 10 cents off. Let's try again with different stuff. How about NAND 8GB on September 29th, 2019. Here are the values. Let's test them. As you can see, it's pretty close. Thank you for checking out our project, and have a great day.